Hi everyone, and welcome to my talk. First of all, I would like to thank you all, because in this world of talks about coroutines, meta-classes, and all new shiny stuff, you prefer to come to something that's going to talk about technology for 15 to 20 years old, which is brave. So this talk is called Early Modern C++, how to handle a C++ 03 code base in the current year, which is cool. You can replace the current year with 2018, or if you're watching from home, whichever year you're still watching this talk. Hopefully, something will have been done. Anyway, the idea of this talk started a bit ago, 2 years ago, about, when I saw this small poll on Twitter, and someone asked, what is modern C++? Because that's a common question, actually. We talk about modern C++ all the time, but when it comes to giving an actual definition, it gets a bit sketchy. So I just looked up that poll, and as you can see, more than half answered that it's basically new standards, C++ 11 or later. And, well, I would like to disagree a bit about that. But let's not get ahead of ourselves. We're going to talk about modern C++, of course. We're going to talk about C++ 03 and modernity, like what's the relationship between the two. We're going to talk about future compatibility. If you try to be ahead of your standard, maybe, how would you do that? And how would you retain compatibility with whatever comes next? And of course, upgrading, because even if I may give you some solutions to your actual problem, I still believe that the ultimate solution for everybody is to plain upgrade to something more recent. So hi, my name is Mathieu. I'm a C++ developer. I work at Paradox Development Studio, where I make a great game called Europa Universalis, fourth of his name. You can reach me on a couple of stuff, email, Twitter. I have a blog on which I talk mostly about build system, even if I try not to. But I also have a couple of posts about that kind of thing. So, working on historical games make you interested in history, of course. This is one of the things that I like, is looking about history. And so this talk is going to look a bit about the history of C++ and where do things come from. I would like to amend something though. It's not because I work on an historical video game that I'm actually using historical stuff, because hey, we're using C++ 14. But what do you know? So, what is modern C++? This is a question that comes a lot. And what do you know when you have a question and you don't have the answer? You ask Google. So let's see. First thing Google answered me when I looked up. So C++ before 2011 and since 2011 are different languages. The first is called classical C++, the second is modern C++. That's the first thing I found when I looked up on Google. And that's also very similar to the results of the poll. And I'm not exactly agreeing with that. So, I mean, what do you do when the first Google answer doesn't work? You try the second one. All right. The second one, I think it's from Microsoft blog at the time, but I would not be exactly sure. Anyway, it says extensive use of the standard library and STL. Exceptions and templates rather than just C with classes. This one is interesting because instead of defining C++ or modern C++ by what it is, it kind of defines it by what it's not. It's not C with classes. We are starting to make progress, but I don't think we're there yet. So continue on the Google. And the next one is the term modern C++ refers to a template-intensive generic style of writing code, which is a great quote because it's both true and kind of hard to understand. But maybe you recognize the source. Anyone knows? Anyone will try a guess? Come on. It's history lesson time. All right, this comes from this book, Modern C++ Design, by Alexandrescu. Who here has read this book or heard about it? About half the audience. So yes, the first time we heard the term modern C++ was in this book in 2001, which makes it 17 years today. And fun fact, all the samples inside are valid C++ 98 that could not compile at the time. But yeah, just the definition and the origin of the term is trying to tell us something. The term is 17 years old. 10 years before C++11. So I really don't think that C++11 is modern C++. In fact, I would like to offer my own definition of what are the tenets of modern C++. The first one, and so probably something you hear a lot around at CppCon and other conferences, is zero-cost abstraction, and even better, expressive zero-cost abstractions. Second one we usually like a lot is strong and regular typing. Third one is concept-based generic programming. We go back to the original code from Alexandre Rescu, which was basically the topic of his book. And the last one is stack-based copying of resources. Am I shocking anyone so far? Okay, they don't look like people are getting angry, so I guess I'm good. All right, let's try to delve a bit into those with some interesting examples. So let's look at this code. Can anyone tell me what it does? Anyone? Reverse, exactly. It's a manually coded reverse. Something that you could probably find in an old C or C++ code base somewhere. That's basically the classic idiomatic way of writing reverse. That is great. And it even has the same performance as the one you would use from the STL if you prefer to write it manually. But things can get sketchy very fast. What if instead of using ints, we're using like things, like complex objects that might allocate memory or store some resources? Well, we have a problem. Our great unoptimized loop is 4.4 times slower. So what can we do? Anyone venture a solution? What is missing? Why am I 4 times 5? That's slower. Swap. Oh, come on, no. Yes, it's the right answer, but usually some people will answer move first. Damn it, it worked at every time I rehearsed it. Anyway, yeah, so the first thing, let's pretend somebody answered move, right? Thank you very much. So move, right, that sounds like the definitive answer, right? Like, of course, I forgot to move stuff, and since we're doing modern C++ here, let's move. That's great. And, well, oops. It's still not great, actually. I would have hoped to get something, but actually I'm not getting much. And yes, the answer was actually not C++11 at all. It was another great algorithm from C++, 98, which is swap. Because that's basically what we're doing, a three-way swap. Except that maybe the compiler or the class has an overload for swap that is faster than the dumb three-way swap. Which gets us back on track. So again, the first solution to remove all and manually generated code was an expressive algorithm that dates back from 98. And even if you really like to write while loops by hand, because that's what people do sometimes, the best option was also an algorithm from 98. So far we're good, right? That's one of the first things we like. We have good abstractions. Instead of writing stuff, we just say, this is what I want to do, and we let the compiler do something probably more clever than what we did manually. Okay. Oh, I forgot to remove some transitions there. All right, the next one is strong and regular types. This is something that C++ gave to in replacement of C, right? Object-oriented programming, or at least the idea that you can have more than structs. You can have iterator. You can have operators. You can have methods. You can basically have behavior to your types. And so the idea is that we can create new types. It's cheap. It doesn't cost anything. We can just create a struct, add some behavior. Methods are not more expensive than functions. It's great. Also, another thing that's pretty interesting is if we have two types that have exactly the same definition but not the same name, we can't mix them up. You can mix up two ints. It's easy. You can't mix up two things that behave like an int unless you intend to. And also, everything can be a value. If you remember C, every time you have to have a type, usually you have a great like alloc on new function, and then a delete function, and everything takes a pointer, because that's how you do. You can have values everywhere in C++, which is great. Let's take a small example of strong typing. So let's say I have a small API that lets me book some basic orders, like I want to buy some securities on the market. I used to work in finance, so that's great. I can write stuff like this, right? I'm going to buy some shares. False means I'm actually buying. Yeah, great API. And we have then the quantity and the price I want to buy it. So I'm basically buying 1,000 shares for $400. Great. Oh, what happens if I write this? Well, it compiles. Fortunately, there's probably no market called Microsoft, so I'm probably gonna get rejected. That's not great, but that's not terrible. I can also probably flip up the Boolean and the quantity. Oh well, so 1,000 is actually true because it's not 0. So I'm gonna try to sell. Wait, what am I? Oh yeah, I'm gonna try to sell 0 shares for $100. Well, trying to sell 0 shares again. Probably gonna get rejected. I'm not losing anything, but of course I can continue working on that, and this is where it gets fun because 1,000 is true. So I'm gonna try to sell 100 shares for false, which is 0. So somebody's gonna be very happy on the market. Is gonna buy 1,000 shares for 0. Great. Of course I could have avoided that easily, right? I could have just like have a bunch of structs or even enum class, but yeah, a bunch of structs. And then, with this exact same API, with just some basic strong types, I could make sure that this works, but this doesn't, because this doesn't, and this doesn't. And the compiler would just see through all of that and just remove everything and translate to the exact same code. It's just that I will catch up a lot of errors. Yesterday at SG40, someone mentioned that he actually made a type for X and Y axis and all because it actually called bugs in his code. Of course, now that we have strong types, we also prefer to have them regular, and usually it means behaves like an int. This is, I think it comes from Scott Mayer's book somewhere in early 2000s, late 90s. Anyway, so the idea is that it has a default value, it can be assigned, it can be copied, and it can be compared, or a bunch of other stuff. String is an example. I can create a string. If I create a string and do nothing, it actually, I can use it. It has an empty value. I can assign another value to a string. I can assign a string to another string, and contrary to like char*, it's not gonna start dangling reference or having a problem with two things sharing the same ownership. I can pass it as a function, and I can even compare it to some literal, and it's gonna work. That's great. Oh, damn slide. All right. Third tenet is what we call concept-based generic programming. Here we delve into the meat of the book where everything from modern C++ originates from, which is basically the idea of duck typing, right? And this is everything that is behind templates. It's like if something looks like a duck, quacks like a duck, and what's the last one? Acts like a duck, it's probably a duck. So yeah, that's the idea that basically all the algorithm library is built onto. If you give me two things that are basically fulfilling some requirements, like an iterator or a predicate or something, a string, whatever, I can just write some generic code that will accept all of these types statically. And the static part is important, right? I mean, anyone use Java? Don't be ashamed, it's not we don't record the audience. Okay, fine. Yeah, so you might know that some other languages do this interesting choice of if you want to do polymorphism, you basically have to re-inherit something. That's how it works. We can do that in C++, that we have virtual for that thing, but that's not the go-to option, right? The go-to option is templates and the fact that what we are concerned about is behavior and not typing. We don't care about where the type comes from, we only care about its properties. Hence the concepts, which is also something that we saw on the keynote Monday. So if you took a look at one of them, for example, predicate. Predicate is something that describes a callable that returns a value testable as bool. I didn't say what it was exactly. It can be a function, of course. It can be a function that returns something that's testable as bool, but it could also be like a function object, any object with an overloaded operator in parentheses, or if we are super modern, it could be a lambda. And it's not even saying it returns bool, right? It's saying a value testable as bool. My function doesn't even have, or my functor or my callable doesn't have to return bool. It can return bool, that works, but it can also return pointer, because it's actually testable as bool, or it can basically return anything for on which if x or if not x is defined. It's anything we can test. And a lot of types can actually overload the operator bool one way or another and be testable. Optional is one of them, for example. Oops. Which leads us to the last one, which is probably the most known one, right? Stack-based copying of resource, also called RAI. I don't think I need to explain a lot about this. I mean, we know RAI, we know smart pointers. We also have like stuff like files, sockets, handles, basically anything that contains a resource and has to free it at some point. And as Herb showed this morning, we can also be very creative with constructors and destructors. In fact, every time someone shows me a language, that's the first question I look for. First I look for like, do you have destructors? And I'm surprised that even in conferences I've seen this year, someone tried to show me a language without a destructor. And some finally or whatever mechanisms, like, I mean, we're here to talk about history, right? And like destructors come from the early days of C++, somewhere in the 80s. That's not new. But still, for some reason, C++ is one of the rare languages to actually do it. And if I want to be a bit creative and not do, well, the classical example, I've worked in databases in the past. So let's say I create a simple transaction object, which just does a simple thing. If the transaction is still pending when I'm running the destructor, I'm just gonna cancel it, roll back. And then if I start doing like some SQL, I can run a bunch of queries, and if something gets wrong and for some reason I just exit the function, well, if I actually reach the path when I run on commits, well, the transaction will be run on the DB, and if not, well, the destructor of transaction will call rollback, which enables us to write all kind of code that doesn't have to have like a bunch of go-to cleanup at the end or some other terrible pattern that we've seen and are usually bug-prone. All right, so I guess we're kind of clear now on what modern C++ is, or I hope my definitions satisfies you. Now the question is, in practice, what does that mean if you're stuck with an older code base? How many of you have come to this talk because they're stuck with C++ 03? More than I thought. Okay, so it's time to wake up a bit because I know lunch is just before. So how many C++ 11 and later concepts or features have been used in the previous chapter? Not zero. Yeah, there was enum class. I added that at the latest minute to the slides and I forgot to patch this one, but you're right. But we mentioned move semantics at some point. Remember, you answered first move semantics and that was the wrong option. I remember it. But after that, since it was bad and you should have said swap instead, we dropped it. I mentioned lambda in some slides. And forget I mentioned enum class, I changed the slide at the last minute, but I mean, I can give you this. All right, but lambdas was one of the first 3 potential alternatives, right? So, all right, I do video games, I'm terrible at math, but let's try. So that's 0, that's 0.3, and, okay. I didn't say, it's start function, I said function. And function dates back from C. The concept of callable is just a concept, and it's also in the STL. We have some callables in early STL, like transform text callable, for example. Anyway, the thing is, we don't have a lot of concept in there. And if you look at all these standards, basically expressive zero-cost abstractions. That's something that's basically one of the motivation of C++ from the start. Like Bjarne has always been talking about this. That dates back from the early 80s or even maybe like late 70s when C front was trying to be developed. Strong and regular types. Again, that's the basis of C++, right? We want to be able to create types for cheap and give them some behavior. So again, like C with classes maybe, somewhere in the 80s. concept-based generic programming. We saw the book, 2001. We already had the STL at the time, which dates back from the mid-90s. But the book itself, okay, I'll give it a pass to 2001. And Rye, all right. Rye, I'm pretty sure you can find some references in some design notes of C++ by Jarne, again, somewhere in 86 or 85 or something like that. Which basically makes the most recent concept of modern C++ 17 years old today. If we say that, if we give the credit to Andre for being the first one, you could try to say that it actually comes back from the early ideas of the STL and Alex Tepelev's work. But I mean, give or take 5 years, it's about 20 years old now. So this is kind of a rhetorical question at this point, but do you really need C++ 11 or later to do modern C++? Come on.
Oh.
Thank you. I like this guy. All right, because there's a bunch of things that you can actually do without C++ 11. Containers, iterators, algorithms, everything. Yeah, working game design, so DLC, whatever. Containers, iterators, and algorithms are something that date back from the STL. You have them in 98, you have them in C++ 03. Rye and destructors, basic feature of the language. Templates. Okay, they've been buggy in the past, but I'm pretty sure that since at least 2003, we have them working. And user-defined types and operators, same thing. It dates back from 20, 30 years now. Of course, that doesn't mean we don't want better features, right? It's not because you have C++ 03 that you cannot look at C++ 11, C++ 14, C++ 17, or even 20 and say, wouldn't it be great if we could have some of those features? It turns out, and I speak from experience there, that you can emulate a bunch of them. Not all of them, but you can actually go pretty far. First guideline I will give you, if you want to do this, write some. I have a support library for that stuff. Like a dedicated library whose only goal is to provide stuff from newer standards that your compiler does not have and ensure that it has an interface that's compatible with standards. Because your idea is that the day you upgrade, because again upgrade is the ultimate goal, you can just do like sed or Control H or whatever search and replace function you have on your IDE and replace your namespace by stub and get out. Think Appcell if you want an example. Appcell is a great example that was shown last year. It does the same thing as this, except it starts with C++ 11. At my previous work, we did the exact same idea about the same time with C++ 03. Before you start writing anything, look up the internet. It's the ultimate source of truth, but it's also the ultimate source of code that you can copy-paste. And Boost is probably the most common thing you could have. I mean, for example, a lot of stuff in Boost was basically an incubator for the standard. Most of the stuff we have in the STL, for example, in C++ 11 and later, comes from Boost, one way or another. Oh, please don't publish under a stud namespace just because it's not available yet. I've seen it. Don't do that. Just use your own namespace. Call it like my company stud whatever, and then you will be able to replace that. If you don't do this, you will never be able to replace that. And since you might try to emulate features from different level of standards and not upgrade everything at once to the latest, you might want to only replace some of them. So make sure you have a namespace. Also, it's very bad practice to put something in stud. But we want lambdas, and lambdas are not just libraries, right? Lambdas is a language feature. We want to be able to write something like this, like small predicate function that just tells me like is the int we have been passed like even? But the thing is, lambdas are not magic. Lambdas are just your compiler generating a function object behind your back. Or if you have a very old and bad compiler, the same thing but worse. I've seen it. But yeah, I mean, it's a bit more verbose, I will grant you that, but it's exactly the same feature. You get the same thing. Okay, we have captures, true, but then again, a capture is just a member variable. So nothing is stopping you from creating a constructor, saving the variable inside your function object and then using it. Again, what's your compiler does behind your back? You can even go crazy with auto, because auto lambdas are not even C++ 11, right? It's C++ 14. But what is auto? It's just a template deduction mechanism. So basically, if you just templatize operator parentheses, you get C++ 14 lambdas. And that thing probably compiles in like 20 years old compilers? Maybe not, but close. So yeah, function objects, they will take some time to write. You would prefer your compiler to write them, but it's strictly equivalent. You will get the same thing as your compiler generates, basically. You can even go crazy and have C++ 14 features in C++ 03 just by using a templated operator in parentheses. And finally, yes, you can't store a lambda without auto, but that's not a problem, because as you've seen in your previous example, as long as you have to make a structure, you have to give it a name. So you get that for free.
But you can't define templates within function scope, so you have to move that struct. In the case of like the auto, it's not strictly equivalent because you have to define it outside function scope.
Yes, that's true. You cannot inline a lambda. Oh, sorry, you want me? Yeah. The question was, can you actually? You can't. The remark, well, the question was that you can't actually define a struct in the middle of a function, while you can with lambdas, and that's true. It's a bit more cumbersome because you cannot inline. As you would with a lambda. You would have to open some namespace, somewhere an anonymous namespace maybe, and just put your type inside. The good side is that it will force you to actually give a name to your lambda. And for example, that's one of the best practices we also recommend. Like if your lambda is more complex than the basic dumb example I've shown, give it a name. Because if not, people on the code review will have no clue what your transform algorithm is trying to do. So I'm not arguing that it's better. I'm arguing that you can get to the same results. Move semantics. That one is a bit tough. Or is it? I mean, we all know how it works, even if we don't have access to them. For example, we want to create some kind of magic handle type that basically is movable but not copyable. Unique pointer is probably one of the most known examples, but any handle to a unique resource is true, like a socket, a file, whatever you cannot basically duplicate at will, but you can move around your code. Well, the good thing is there is boost. And again, this is macros, this is ugly, and Herb this morning told us that macros are ugly, and then use them. So I'm going to do the same thing. And I'm going to use a bunch of macros to show you that you can actually write with just about the same length, move only types in C++ 03. And the good thing with boost move is that if your compiler actually supports move semantics, it will emit basically the same thing as on the left. If not, it will be clever with templates and do some smart emulation. So look at boost move. It's header only, as most of boost. You can integrate it with most compilers these days and use it in your code. It's not as great because you cannot default. For example, you can't have default. So you can't default. You can't have a default constructor. You can't have move by default on all the types, which is what C++ 11 gives you. So I would encourage you to reserve that for handle types you would have to manage, or if you have a performance bottleneck. If something is very slow and you're just passing it everywhere, make it movable, and you might get some performance benefits. You will not have it as widespread as the normal move semantics, and I wouldn't even recommend it to widespread because then you have to remove all the macros. But localized, if you need to have some specific types, again, 2 years ago I presented a SQL library. The original implementation was C++ 03, and everything was movable with using the same tricks. Also remember that move is not always a silver bullet. If you ever try to move an array of ints, you would have noticed that it's just as fast as copying it. Sometimes moves can actually help because there are resources you can just steal. But if it's just raw data, you're just gonna make a copy anyway. Then comes most of the stuff that you would like to take from the standard library. And as I said before, most of them come from Boost. This is turning into a Boost talk, right? Oh, well. So yeah, type traits, unique pointer, shape pointer, array, function, bind. I'm not recommending you to use bind, but it's also in Boost. Optional variants, it's C++ 17, but it's already in Boost. Threading modules. You don't have to rewrite this, if you can. And if you don't, well, you can actually rewrite this. I'm not going to say it's painless or it's costless, but if you have to do it because of licensing reasons, all that stuff, well, you can say that there is prior art, there is stuff you can look up, there are some patterns that are like publicly available. You can reuse them if you have to write it yourself. Still, since we're on topic of Boost, be careful of API differences. Because Boost was an incubator to the standard, but then there was discussion in the committee, and then something was standardized. Most of the time it was the same API, but some small things might have changed in the process. Some APIs are actually a bit different on the standard version compared to the Boost version, and Boost did not go back and break the code of all its users, so it's still there. So what I would recommend you, if you want to use such types and make sure it doesn't start spreading non-standard use in your code, put a static analyzer to just like block usages of that code, or if you can't, you can use a wrapper, or you can even, if you have a copy of Boost, I wouldn't recommend, that would not be my first recommendation, but if you have a copy of Boost, you can also maybe simply remove some of the stuff that you don't, or mark it with some kind of, I don't know, you don't have attributes. You can put some marking in there, just to say like, this is not standard, don't use it. And if it's not that, just just make a small wrapper type, then the compiler will just inline. The idea is that you want to keep the same API as the standard library, because then that day you will just be able to say sed to stud namespace and done. You might want to be crazy with metaprogramming, because that's fun. I do that sometimes. And yes, you don't have auto, you don't have decal type, you don't have decal val, you don't have variadex. But have you read Andre's book? That's one of the reasons I asked. Because if you haven't, you would be surprised, and if you have, you're probably surprised too, when you read it, of how much you can do with C++ or free templates. Like that's crazy. I'm not saying it's easy, but it's crazy. I mean, Boost uses that. A lot of library uses that. With a colleague of mine, we wrote variants in C++ or free just using type lists. You can go really, really, really fast. You can write expression templates. You have Sphinx, you have the overloads, you have all the basic building block to create crazy metaprogramming if you really have to. It's more cumbersome, certainly. It takes a bit more time. You have some queries left and right, but you can do very, very, very large stuff without all of this. You might also need macros. I'm really sorry about that. All right. So, yeah. When I pitched this talk, I actually asked a couple of people at my meetup, trying to pitch the talk. Do you think this is going to be something interesting that I should push to CppCon? Some people are like, yeah, great, I want you to teach all my colleagues about that. And we're like, oh no, certainly not. Because my boss is going to see this talk and say, oh great, I don't need to upgrade anymore, because actually you don't need C++ 11 or later. You can do everything with C++ 3. That's great. And that's, okay, so if you're this boss, well, just refer to the time code, and that's going to appear somewhere in this video, and just show it that part only. Okay, so why should I upgrade? That's a big question, right? I mean, especially since this guy just told me I don't. What do you do? Well, it's not exactly what I said. What I said is, there are two different concerns. Modern C++ concerns itself with idioms and philosophy. What C++ has been built for, how should we use it, what's the direction we are taking, what are the patterns and best practices we want to introduce. It's not tied to a particular version. Like we shown before, most of the tenants dates back for 20, 30 years. Yeah, older than a decade. I was generous with that. On the other hand, new standard revision are concerned about giving you guys more productivity, better vocabulary, and better performance. Let's delve a bit into that, since this is the only part your boss is going to watch. Hi, boss. So, productivity. Well, okay, so we can actually write fronters. That's great, but lambdas are actually faster to write. And as someone just asked before, you cannot write them in line. You have to actually put them in some other places, which is good in some places and kind of boring in some others. Although it's great. I know we have started to scale back since Monday, but still, although it's great and it's never wrong. I can be wrong when I put the type on the left. Auto is not. It's my compiler telling me what the type is. And if you ever done some meta-programming and compare how you can write something with constexpr and how you would have to write it with recursive templates, you would find compile time code much simpler and easier to write with constexpr. So basically, you will get some huge productivity benefits on your day-to-day job because you don't have to integrate third-party libraries and then maintain them. And basically, we added a lot of nice small things that help you every day. That's why we have default. That's why we'll get spaceship. It's because, yeah, you can write everything yourself 10 times. Have you seen Odin's talk about optional? I think it was on Monday. It's shown how many... No, that wasn't Odin, sorry. That was... Someone help me there. Simon, thank you very much. Yeah, Simon's talk about optional and how there is a lot of stuff that you have to duplicate and how future standard will help reducing that. That's basically how a lot of stuff we do every time. It's like, oh, this thing is very, very, very painful to write and rewrite and rewrite. Can we just have a feature that does that for us? We're lazy and that's a good thing. A vocabulary is probably the one that is the most commonly forget when we actually talk about the good thing from a new compiler. Because here is the thing. Let's say you have to talk to another library. What can you agree on with C++ or free? You can agree on what's a string. You can agree on what's a range because you have iterator concepts. You can even agree on some actual concrete container types, like vector, map. That's great. But that's a bit bare-bone, right? Like, how do you agree on what a thread is? Date, a file, a socket. Well, you can't, because there's nothing in the language that everybody shares that actually defines it. You just have to both use the same library, or option B, write a lot of boilerplate to convert type A from type B because everyone has rewritten everything in that because it needed to actually manipulate dates. I don't know how we actually waited for like 2011 to need dates. I mean, I'm pretty sure somebody needed dates before 2011. That's not really a new concept, right? Interoperability is probably something that comes back from the same idea. It's not because you restrict yourself to C++ or free that whatever library you use will. And what if your vendor at some point says, oh, we're not supporting C++ 11 anymore? That happened. That happens every day. And like all the cool kids that make new libraries, they won't target C++ or free. I mean, Absol, for example, is a great compatibility library. They started at C++ 11. Ranges need at least 14 or 17, depending on your compiler. And a lot of new stuff needs new standards. And even old stuff at some point upgrade and say, you know what, we're dropping C++ or free because it's too painful to maintain. What you're going to do, you stop upgrading, and then you get a critical bug. And then you ask the vendor and say, nope, I'm not going to backport a critical fix for something that's in another language 3 years ago. So you will have to do it yourself, possibly in a code that has been refactored to use the new standard. That's not going to be fun. Performance, of course. I mean, C++ is all about performance, right? So it's a small experiment that had been done. I don't have the code right there, but when C++11 was introduced in production, a lot of people reported that you can get production performance benefit just by putting -.c++11 on the command line and be done with it. One of the big reasons is that it will put move semantics everywhere for free, and then everywhere it can move instead of copy, it will do that. And you also got an RVO and a couple of other stuff that basically cuts sometimes copies. Also, most of the time, the reason you can't upgrade standard is because you can't upgrade the compiler, right? I mean, if your compiler was actually able to support new standard, you would probably use it. There is a very, very small list of features that have been deprecated. They would stop you from upgrading, and that comes from C++17 mostly. On C++11, if your compiler supported it, you would mostly, I think, enable it. So you would have to change compiler. And what comes with new compilers? Well, bug fixes first. I mean, who haven't used like old compilers and bugs? You would get performance benefits. I mean, that's the thing I actually noticed. Like, my production servers are upgraded every 2 years or every year. I always get the latest Xeon from Intel, but I'm still building from something that think that Pentium 3 is a thing. Like, no, it's not. No, we changed the CPUs. They became increasingly more complex. And the reason we can get good performance is that the actual compiler knows, like, oh, this instruction is too costly. We have to do something. If you see Matt Goldwald's talk from last year, for example, he showed some example of when the compiler decides to inline divide because it's actually very slow on this architecture, and then said that after some point it stops and just you divide from the CPU because it's actually good now. I mean, Intel, AMD, whatever CPU vendors, they upgrade the CPU all the time, and we upgrade compiler to catch it. Even if you use C++03 with an older compiler, you would probably see the performance benefits because it would actually be use your CPU. And to me, it's very weird that you would buy new CPUs every year, but still use a compiler that's not going to be able to use like half the instruction set. That doesn't make sense. And this is the most icky part. That's actually the one that people don't like to talk about it, but I will. So here's the thing: students these days, if they want to learn C++, if they're not going to learn C++03, I mean, some university maybe still are like caught up with C++03. But I mean, I had candidates and they studied C++ on their own. They just open the internet and say, oh, I want to learn this C++ thing. They don't start with C++03, they start with 14 or 17, depending on what they can get. And this is actually a dreaded question these days. When you have someone in an interview and he says at some point, like, do you have any question? And he's like, yes, which C++ standard are you on? And you can see the interviewer sweating very hard, like, we are in the process of upgrading. Yeah, I see a couple people in there, and you know what I'm talking about. Yes, so here's the thing. C++03 is not really something attractive that you want to put on your CV. I mean, I'm not saying it's COBOL or Fortran, right? But I mean, that's not the thing that you think will land you a job tomorrow, because let's face it, less and less people stay in the same company for their whole life. So you're actually trying to build your skill sets. And C++03 is starting to be something that's not that attractive to sell. And people will turn down offers. And people will leave the company because they think that they're stagnating and just working on stuff that's just basically deprecated. And no one likes being deprecated. I mean, we are in tech because we like new shiny stuff. I don't say that neophilia is a good reason enough to move. But there are actually some industry valid reason to want to have better tech. And with that, we are coming to the conclusion, and since I like to repeat a bit to leave an impact, do I need C++11 or later to do modern C++? No. Is it actually a good reason to stick to C++03? No, no. I like this guy, really. And with that, thank you very much. Any questions? I didn't get too technical on the upgrade part, for example, so if you have some of them, fire up. If it's not technical, you can also ask.
You talked about having a wrapper library in order to produce
Yes.
compatibility. My question's pretty simple. You talked about having wrapper class or wrapper class in order to ensure forward compatibility. Do you have any examples of that as to how to go about? Because there are certain limitations with some of the Boost library and things like that makes it pretty incompatible with the standard. And so how do you take and you transform in order to fix the Boost so that you have a good drop-in replacement for?
Well, I would say probably the easiest way, if you can, is just make create a type that just privately includes whatever Boost use, but shows the same API and then calls Boost behind the scenes, possibly with the different with a different semantic if they actually deviate from the standard. It's a lot of boilerplate because it's basically a proxy object. The compiler should be able to inline most of it because it's basically a flat object that just contains another one and no additional data. But it should do the trick.
Okay.
What are your recommendations for upgrading a large code base?
Okay. What do you mean exactly? In terms of compilers or?
So we go through all the work to convince our bosses to let us use a newer compiler that's C++ 11 plus capable.
Yes.
And they're like, okay, now you go through and upgrade everything to C++ 11.
Well, you don't have to upgrade everything, right? C++03 still compiles in C++ 11.
Correct.
So the only thing that would directly block you from changing the compiler is something that would be deprecated. But there is basically almost nothing in C++ 11 that is deprecated from C++ 03. I mean, you might get a warning on autoputter, and I'm not even sure you get a warning. I think you have to start with C++ 14 to get a warning on the fact that you use auto. Maybe auto pointer will generate some warnings because it's a deprecated type. And a couple of STL functions might do that, like random shuffle and other algorithms that are basically deprecated. But that's not that much. Well, maybe if you're a huge user of auto pointer, you might have to replace that with unique. I think you can use Clang Modernize for that. There is a Clang-based tool. Sorry? Yeah, Clang-Tidy has a modernized check. I'm pretty sure that is able to offer drop-in replacement for your auto pointers to your unique pointers.
Okay.
You can also temporarily disable the warning if you're really in a hurry. I'm not recommending that, but depending on your budget.
Okay, thank you.
Well, if anyone has another question, I'm still around the conference for a couple of days. Thank you very much.